Okay, we are live. I want to thank everybody for showing up for tonight. I wanted to start a little bit earlier. Just want to make sure that everything is working fine, that I got the bugs all figured out from last night. Last night I tried for a little bit, did not get the sound exactly the way I wanted it to. And as I said last night, I had the microphone that was out at one of the webcams, and it screwed up. But I think we got it all figured out, and I'm hoping that tonight will go a little bit smoother. So, without further ado, I'm going to show everybody tonight, and I want to thank for everybody who is showing up tonight to view the image session that I have going on. Just want to make sure that everything goes well. What I plan on getting tonight is it looks a little bit clearer than it was last night, as I polar aligned, got everything all set up before now, which takes about 15-20 minutes to get everything all set up. What I could just do is I can run a loop, and what this is doing is it's taking a 4-second exposure, which is the Orion camera, and what this is doing is it's taking one exposure after another, and you can tell that it is just going through and taking one picture. And you can see that it's not really moving, so that's actually a good thing. Doing is we're going to be tracking tonight, and I'm going to be using the Meade DSI camera, and I'm actually going to be pulling that up right now as we speak on one of the other, which is the PhD device that uses for the DSI. I'm going to be having the Facebook page open for any questions or anything that anybody asks. I can answer for them. So if you just go right to the actual Facebook page itself, then from there, you can use that, and then I can answer any questions if there's any requests. And then we can go from there. Using the tracker, the PhD guiding, and it's using a separate scope on there with the Meade DSI. It's a monochrome camera, color camera, chrome. And what this is going to do is it is going to track. Right now, it's moving up a distance of west each step. When it gets to a certain point, then it's going to go back east and it's going to head back down. Then it's going to go north and then south, and it's going to correct the errors in the mount. The little notebook that is definitely doing the trick, but going live and running all these astronomy programs, I don't know if that is going to be enough, but we're going to try. And you can only do so much. I may have to invest into a better laptop or notebook, but so far so good. What it's doing right now, as I said, it's still going west. Right now we're at a distance of 22.8. That is the pixels. And again, this is for guiding. If you do not guide, for the new astronomers out there, if you do not guide, you could probably get, if you're polar aligned, 60 seconds if you're really good with polar alignment, and that's 60 seconds on tracking on a star. If you are guiding, you can get roughly between 400 to 800 seconds, and that is guiding on one star. And what it does is it shows RA and DEC, which is right ascension and declination. That is what is on a mount. That's for an equatorial mount. So right now we're going back east. We are at east step 24. And what it's doing is it's counting it down. So you can see now the actual distance should go back down. It's at 20.2. Now it's 19.4. So as you can see, it is going down, which is good. And when it gets back into the center of those yellow crosshairs, then it's going to clear the backlash. And the backlash is just extra slop in the motors for the equatorial mount. And then it will go north and then south. And then from there, that's when I'll be able to track and then I'll be able to get a really solid image without any problems at all. So right now it is still tracking, it's still guiding, and I'm showing this for presentation purposes, so this way everybody can see exactly what it is. So this way you don't need to make the trip out here and sit here. You can do it right from home, which is really nice. So this is going to be a start of something new, and hopefully, as I said to a few people over the last couple of days, is that this is new, so bear with me. I'm trying, and this is something that could lead to other things. I could be able to do planetary later. Waiting to get an 8-inch telescope. It would be a Cassegrain, and then I could be able to get Saturn, Jupiter, Mars from home, which is nice. So that is in due time. So right now we're only looking to do deep sky. Deep sky from here, from Western New York, is really not that bad. We are sitting in the red zone for the Bortle scale, and what they do for the Bortle scale is they classify it based off if you're in a city, suburbs, country, or in the middle of nowhere. And the color scale is listed from white, which is in the inner city, to red, which is the outskirts, but still in the actual city, and that could be Buffalo, Cleveland, Columbus, New York City, and so on. More lights, which is more light pollution, the less stars that you see out in the sky. From here, I could probably see 45, 50 stars of the bright ones. And if you really look and have the dark, adaption, you could probably get closer to 100. From a dark sky site, hence Cherry Springs, which is near Coudersport, Pennsylvania, you're talking in the thousands, tens of thousands of stars, because it is in the middle of nowhere, which is good. It's not near any major cities, and it's a lot better. So around here, you're not going to get as many stars, and light pollution wipes out a lot, and you really can't see much. Hence, that's why you need light pollution filters. You need higher-end CCDs and cameras, and that will eliminate most of the light pollution that is around where an inner city. But following the Bortle scale, after the red goes orange, then yellow, green, gray, and black. Black is the darkest you can go in astronomer's nirvana. If anybody has ever gotten a chance to go out to Cherry Springs or I forgot the other one in West Virginia, Spruce Knob, I think is the name of the place of that one. Those are dark sky sites. They're preserved. And with that one, you can actually see the Milky Way. And then if you ever get a chance to go out to one of those places, it would be in your best interest, because when I went out there in May of 2013, it was one of the best times I've ever had in my life. And to see the Milky Way with your own eyes and to actually capture it with a DSLR or point and shoot camera to get it for 20 seconds, with that, as an astronomer, that's priceless. And it's something that a lot of people should do. And I'm planning on trying to go in September, maybe next June, but they have the star parties every year. They have 2 a year out at Cherry Springs in Pennsylvania. And there's about 400 to 500 astronomers that go there. And they stay 3 nights, Thursday, Friday, and Saturday, and they leave on Sunday. Some even actually go on Wednesday. Some even go on Tuesday, depending on if the weather's really, really nice. They will actually go out there and actually get it. So and some of the pictures I took out there, and I'm going to be posting them on the Facebook page. So this way you'll be able to see the difference. I have a few of them where you can compare the light pollution compared to dark sky sites. And it is immense. I mean, even going to North Java for the Buffalo Astronomical Association, I'm a proud member of that, and going into the Beaver Meadow Observatory out in North Java, the skies there are beautiful. I mean, not exactly for Cherry Springs, but you can see the Milky Way on an August night if it's clear, with no moon, but you can definitely see the sky, and it's really, really nice. So definitely message me. I mean, if anybody ever wants to go with me, by all means. It's unbelievable. But what we're going to do here is that we're almost done. We're going on North Step now. Being a little sidetracked, but that is fine, because as an astronomer, a lot of the times, and you're just going through the motions. So when you go online and you look at the pictures from astronomers and you say, wow, that's a pretty picture, or that's really nice, just remember it takes a lot of work and it takes a lot of effort to get these pictures, especially the ones that are, long exposure, photography. Like if you're going to do a 10-minute exposure, you have to sit there for 10 minutes and wait for that exposure to come out 6, 7, 8, 9 times, and then you have to stack it. And I'll have a few videos later on to show what that does, and that's really cool. That is really nice to process the image after you stack it, and then you can see the difference between one image compared to 10 or 11 stacked and processed. Right now it's still a little bit about a background of what I've been doing since I started. A lot of burning questions for newcomers that are watching this video, or even people that are going to be watching it later on. That I started astronomy especially with astrophotography and viewing the very first time. I started in astronomy in May of 2012. So this month actually marks the 4th, going into the 5th year of doing astrophotography and just viewing. The first telescope I had was a Meade ETX 90 Cassegrain. It's a little blue telescope that came with a case. And it's a tabletop telescope, and it was a good telescope to start out with. 90 millimeters means it's roughly 25 millimeters per inch. So you're looking at about 3.5 inches in aperture. Aperture is the distance of the width of the mirror. It's a 3.5 inch telescope and served its purpose as the first telescope, which was really nice. Rings of Saturn, you can see Jupiter very well and its moons, and it had a pretty good field of view. Wasn't the best ever, but it did the trick, as it was a tabletop, so it was very portable. You can move it left, you can move it right, you can take it off the table, you can go somewhere, and you can view anything you wanted. The next telescope, I decided I made a mistake and wanted to go big. I went with an 8-inch Dobsonian. It was a collapsible trussed tube, so that made it a little bit portable. However, it was like 60 pounds, and it was very heavy. Is the aperture, so as I went from 3.5 to 8 inches, I more than doubled the aperture, which means magnifying a lot more. The optics were really good. It was a Skywatcher, and it was a really, really good telescope. However, it was not a computer telescope. It did not track. It was all manual. So if I wanted to view something, there was no go-to. I had to find it myself. And if I found it, I'd have to keep moving it every 3 seconds, as it would go out of the field of view. That was great for views of planetary, such as Jupiter, Saturn, Mars was really nice. I have a few pictures up on my website, which is www.elliott-astronomy.com, and I have a lot of pictures of the moon, a lot of pictures of Jupiter, Saturn, and whatnot, of all the planets in the solar system. Then after that, I decided that I wanted to go with the reflector with a tracking mount. At that point, I was heading out to the observatory a lot and seeing what other people had, and I wanted to actually get into the astrophotography. At that time, I was about my third year in, and I wanted to get involved. I wanted to do that kind of stuff, which was kind of nice. A Celestron 6-inch reflector on a CG4 mount. So I had to learn how to use the mount, the telescope. My first camera that I ever used in T3i DSLR. Really well. That worked out really well with. If anybody ever had a chance to do astronomy or astrophotography, definitely go into the DSLR. I'll put up a few links on my page, and you'll be able to see what it looks like. So that'll be really cool. So had that for about a year and a half, and then decided too heavy. The payload on the CG4 was getting too much. So then I decided to go with the CG5, which is one step up from that. And that is actually the mount that I'm using now. So this CG5 Advanced GT mount. And I sold the 6-inch reflector to go with a refractor. And right now, currently, I am using a William Optics 80mm Zenith Star apochromatic refractor. I know that's a tongue twister, and that is a lot. But I will post a picture again on the Facebook page, on the event page, and whatnot. So then you could be able to see what the telescope that I'm actually using, the mount that I'm using. I'm actually using currently a dual setup. And I'll put more pictures up on the page and whatnot. Second setup I'm using is a macro lens. It is a Sigma lens. With that is where you see on the actual current screen is the Orion Camera Studio. That is the Orion G3. It is a deep space camera. The sensor size is really small. And I'm going to show you the difference in a few minutes here when we actually are tracking. It's just about there. And then we'll be tracking. Let me pull up, and I hope this doesn't lag out the system. The QHY9C. This is the expensive CCD. It's not the most expensive. There are a ton of CCD cameras out there. QHY10, QHY12. Just like anything you buy, there's always a new thing that comes out, and it's better. The best bet is to start small and work your way up through the hobby. Buy something, use it for a couple years, maybe even a year and a half, sell it, move the step up. And then from there, the hobby. When I had the 8-inch, it worked out really well. Andromeda Galaxy is. I got to learn where the Hercules cluster is. The objects, where each star is, when it rose, when it's set. And it was really cool to see everything, to actually physically, and you felt accomplished. And that was really cool. It's pretty easy now when you have a go-to computerized telescope. And then it goes right there, and then you don't have to worry about it. Different now. I could sit here and actually do astronomy about anything. When I do get a newer laptop, I will be running the Starry Night, and I'm going to actually put the mouse right over it. the Starry Night 7, and it is an astronomy program. And we're just going to take a preview image just to see what it looks like, see how we're doing with this. Now, with this one is, it is a little bit bigger sensor, so it is a bigger field of view. The star that you see here is Vega. The brightest stars in the sky, 3 that make the summer triangle, and you can see those with your naked eye. They are roughly about 1 to 2 magnitude. So when we start the next session of when it's clear again, this will already be done, and I'll be able to just go right into it. I just wanted to show everybody what this entails to start a session, to actually start. Go out, wheel out the telescope and the mount and everything outside. It's actually the first true imaging session that I'm actually doing. And I'm going to work with it, and I'm going to try to do the best I can. So, with that being said, I want to thank everybody for watching. And I will talk to everybody on the next clear night. Thank you for watching.